In this series, we're gonna focus on practical physics, that is alternative practical, okay, on the topic simple pendulum experiment. So, right, this is how the practical is. Most of us will have a different practical manual, but just know that is the same approach method or the same method of approach, okay. So we have this. Okay, is the this is how the practical manual looks like, okay. This is how the practical manual looks like, okay. So some of us will have these are the questions which we are going to consider here in this session. All you just have to do is to hit the subscribe button to get the full video. Now, some faculty will have something like this. Of course, if you look into this one and this one, they are not the same. They are not the same here. This one has T1, T2 only, and T mean, okay? But the method of approach is the same. Please take note of that, okay? So any method I use to solve this guy here is the same method you use to solve this guy here. Please take note. So if you look into this one here, we have T1, T2, T3, T4, T5. Of course, this one is a kind of advanced to this guy here. So I'm going to use the advanced one. If you can understand the advanced one, you can understand the simpler one, okay, which is this one here. Okay. Now let's just consider this experiment here. They gave us a formula that is T represent period. If you read this statement here, T represent period, okay, is equal to 2 pi square root of L over G. So this L here is the length, G is acceleration due to gravity, okay. And how do we state the aim of this experiment here? Everything we are doing here depends on this particular formula. You can use this formula here to determine your aim. You can use this formula here to calculate your values. Remember, we have two methods of practicals. We have the alternative, we have the main practical, that is the one you use apparatus. Please take note. But in this session here, I'm going to use the formula method, that is without any apparatus at all, to calculate the values here, okay. And it's going to give us the same values you will have when you conduct this particular practical, okay. So class, in this formula here, we have T equal to 2 pi square root of L over G. Of course, this is the table, and we are going to calculate the values later. Now, in this table here, this table 1, we are giving term oscillation. This table 2, the difference of table 1 and table 2 is the oscillation. We are giving 30 oscillation. That means whenever you are solving this here, you use the oscillation as 30. We are going to know what oscillation is. While in this table 3 here, we have to write down the period of the t square on term oscillation, which is this one here, 30 oscillation, which is this one here, which is this one here. For 30 oscillation, this one here, there is t square of 30 oscillation, okay. So the difference between the height of this guy and this guy is that we'll plus up the height with the radius. So how do we measure the radius? We use vernier caliper to measure the pendulum bob. Please take note, for those that will be doing the practical, you use vernier caliper to measure the radius. But using vernier caliper, we don't use vernier caliper to measure radius. Of course, we use vernier caliper to measure the diameter. And if you can have the diameter of any object, that means you can easily calculate the radius. Please take note of that, okay. So I will recap what I told you guys here, but just calm down and listen carefully. This is experiment 4, and the aim of this experiment is to calculate the acceleration due to gravity. Of course, it's written here, that is the title or the aim. Please take note. Of course, there's no need for you to write apparatus here, it's already given to you here, okay. So our aim here, like our intention here is to use this formula here to calculate the values here. So now let's try to conduct this practical using formula method without any apparatus, okay. Let's use this formula here. let's use this formula here to calculate the values here. So let's first of all solve for 10 oscillation, and we also solve for 30 oscillation before we answer these questions here. Okay, so this is the table here. Please, I'm sorry for how the table looks like. You know, it's a kind of stylus pen, so it's not going to be neat as you expected. Okay, now we have the height to be in cm. That is, we are giving height as 120, 180, 60, 40. So all the unit of this here, they are all in cm. Please take note. While we are giving time 1, that is t1, t2, t3, t4, and the mean time. Okay, we are giving period, that is t, calculate at t. We are giving t square. Okay, now how do we use this formula here? How do we use this formula here? It's in your practical manual. How do we use this formula here? Or this one here is also in the think okay, you see it in, okay, this formula here to calculate for the values. Okay, it's a kind of strange to some persons how they can use formulas to conduct practicals, but this is the most accurate method to use if you want to get the real values. Okay, but before we use the formula here to calculate, remember the intention or the purpose of this practical is to calculate acceleration due to gravity. And please take note of this before we start. And acceleration due to gravity is ranging from this, that is this g here, is ranging from 954 in cm per second square to 100 1006 cm cm per second square. Please take note of this. Okay, so remember this is in cm, it's not in meter. If you want to convert this to meter, that means you divide this by, if you want to convert this down here to meter, that means you divide it by 100. Please take note. If you want to convert this one to meter, divide it by 100, you have, this one will be 10.06, which is approximately 10 cm, 10 meter per second square. So if you convert this one here to um to meter, it will be 9.54 meter per second square. Please take note. But we are using cm because of the unit in this table here. The unit of length or the height is in cm. Please take note. We are working according to the table. Okay, but class, the perfect value, any value you calculate in your manual as g can either be 954 to the range of, range means 954, 955, 956 to this 1006. Please take note. So if you calculate your value to be 9 meter per second square, it's in line with the value of g. Please listen to me carefully. The value of g is not always 9.8 and 10 in experiment. Okay, can only be 9.8 and 10 in normal calculation, that is in an ID calculation. But in practical, we can make mistake. That is why they gave us a range. So that range can either be from 954 to 1006. That means if you conduct your practical and the value of g is giving you as 955, you are also in line with the value of g. That is, your value is also correct. But if you solve and your value is 4 something, is out of this range here. Please take note. If you solve and your value is 11 or 11 something, is out of this range. Please take note. Okay, so the range of g is 954 cm per second square to 1006 cm per second square. Please take note of this, okay? But we all know that if we say the range of G is this class, it also means that the value of G can also be this, that is 980 cm per second square. 980 cm per second square is also part of, is also part of the value. Please take note. So this is actually the accurate value also. Please take note of this. So if I want to use formulas method, remember the formula is this, that is T is equal to 2 pi square root of L over G. Remember this formula here. Okay, I want to use this formula here. For me to use this formula here, first of all, the subject for formula here is T. I want to calculate T. So how can I calculate T? Of course, the L here is given to us, that is the length or the height, is given to us as in the values in the table there as 120 for this, 100 for this, 80, 60, 40. Please take note. But the only thing here that is not given to us here is G. Please take note. So how can we calculate? You can choose any value of G here. You can choose any value of G from this range here for us to calculate T. Okay, now what value am I going to choose? I'll choose the value, since this is the exact value that you are asked to calculate in the practical. Please understand this. So I'll choose a value that is closer to this, but not exact value of this. So when you choose that value, we'll choose 970. Okay, just 970 cm per second square. Okay, so let's input the values here. I chose 970 because it's closer to 980. Please take note. So if you are choosing 980, that means you're already on a perfect value. So you might not have an accurate answer. You can choose any number though, but I always tell my students to choose 970, okay, for accuracy, okay. So let's input the values here. When you do that, our T will be equal to 2 times 3.142, the value of pi, times square root of the first length there is 120 over 970. Okay, so when you point your calculator here, here 120 divided by 970, square root of it will give us this will give us this one here only, 2 times 3.12142 will give us 6.284 times this one here. When you punch your calculator here, that is 120 divided by 970, square root of it will give us this, will give us 0.35. So our value here is 2.21, sorry, 2.210. Okay, 2.210. Okay, so that is for this. We go to the, okay, later we input the values here. Okay, so we write 2.21. Okay, in your table we approximate the values to be in 2 decimal places. Please take note. In your table we use 2 decimal places, but if the lab attendant instruct you guys to use a specific decimal place, you can use. But in a standard way, or in a standard practice, if it's practical, we use 2 decimal places. Please take note of that. Okay, so the next one here is when L is equal to 100. When L is equal to 100 cm, so the value of T here will be equal to class, the value of the T here will be equal to, remember the formula, 2 pi square root of L over G. So this is 2 times by 970 is 0.22118. And when you punch your calculator, our answer is 2.0177. Please take note. So I will impute 2.02. Okay. Now let's solve when L is equal to L is equal to 80 cm from the table there. That means our T from the formula first equal to 2 pi square root of 2 pi square root of L over G. That is 2 times 3.142 times square root of 80 divided by 970. Okay, in case this part is confusing here, you can use any one. You still get the same graph. You still get the same answer. Okay, like you still get the same graph method. Okay, now in practical, the values are not a kind of important. What is important is the graph method. If you use maybe 980 cm per second square, or you choose any value of G, you still get the same pattern of graph. Okay, please take note of that. Okay, now our answer here is this will give us 2 times 3.142 will give us 6.284 times 80 divided by 970. Square root of the answer will give us 0.2872. So our answer here is 1.804659. Okay, now the next one is when L is equal to 60 cm. So 2 pi, our T, which is the period here, our T is equal to class. T is equal to 2 pi square root of L over G equal to 2 times 3.142 times square root of 60 over 970. So the answer to this is 1.563. So the next one here is when L is equal to 40, our T is equal to 2 pi square root of L over G is equal to 2 times 3.142 times square root of 40 over 970. Okay, my answer here is 1.27609. So these are the values of T. So now let's place the values of T here in the table. The first value of T is 2.21. Remember, I told us that in our table we use 2 decimal places to fit in our manual. Please take note. Okay, the next one here is 2.0177. So I can say 2.02. So the next one here is 1.804659. I can say 1.80. Okay, the next one here is 1.563. I can say 1.6. 1.56. The last one here is 1.27609. I can say 1.27228 and so 1.28. Okay, we have calculated for the period, that is the t here. The next here is for us to calculate for the mean time, that is the average. Some of the practical they will put average. Mean is the same thing as average. Okay, I will explain that later, please. Okay, let's calculate the next parameter here. Now the next parameter here related to, we are done with this here. The next parameter here related with period is the mean time. Please take note of that. Okay, so to calculate this one, to complete this one is very simple. Since we have t, we can square these values, but we are coming for that. Okay, we are coming for that. So we are asked to calculate. The only parameter here connected with period here is this here. The second one is this. So now how do we connect the formula of mean time to period? Now remember that there is a particular formula related to period and time with number of oscillation. Okay, we say that period here t is the same thing as t over n, which is number of oscillation. Please remember this formula here. So whenever you are giving number of oscillation, you are giving time taking, the only formula to use here is this formula here for period. Please take note of that. Okay, but if you look into this table here, we have various formulas of time taking. Okay, we have t1, t2, t3, t4. So for me to summarize that here, that is t1, t2, t3, t4. Some might have t5. For me to summarize that, you call it t mean. T mean means the average of all the time. Okay, so that means using the formula here, period here will be equal to t mean over n, that is number of oscillation. So in our practical here, we are giving number of oscillation. If you look into this practical here, the number of oscillation here is 10 oscillation. So it changes depending on this. This is 30, of course. Okay, so the number of oscillation here is, for this one here, for table 1, is equal to 10 oscillation. 10 oscillation. Okay, so that means anywhere I see n here, this n here represent number of oscillation. I will input 10. Okay, why? For the period here, for this part here, for this one here, is given to us as 2.21. So we can easily make tm this subject here. So our tm here is equal to n of t, which is the same as 10 times 2.21. Okay, the 2.21 here is the value of period at 120. Please remember, the value of period at 120 is 2.210, which is the same as 2.21. Okay, so class, it means that the formula connecting um average time, which is the same thing as t mean, with number of oscillation and period, is this particular formula here, which means multiply the number of oscillation by the period, which is t here. So this is the formula. There are 10 times 2.21 will give us 20 2.1, that is, I have this to be 20 22.10. I put in that 10 to approximate to two decimal places. So to find this part here, remember that the formula connecting the period and the mean time is n times t. So not going too far, because this is practical and you are being timed, we multiply this by 10. I will have this to be 20.20. That is 20 point, this is 20.20. By this one will be 18 18.00. This one will be 15.60. This one will be 12.80. Okay, so the next one here, class, is to calculate for T1. We are almost done. T1, T2, T3, T4. It's very simple. I will show the shortcut here to get the answers. Okay, now let's calculate for, first of all, let's calculate for the T1, T2 first. Okay, so for T1, T2, anything that happen with T1, T2 is the same that will happen with T3, T4. Okay, now let's move into that. These two numbers like this, 2, 1, 3. And you're asked to find the mean of this. What will you do? It will be 2 plus 1 plus 3 over 3. Remember, so the same thing here. The mean of the two time, that is T1 and T2, is this. That is, I would say T mean is equal to T1 plus T2 over 2. We are solving for the two time, for that is the two first before we solve for the next one. Okay, so this is already given to us here. Our intention is to find T1 and T2. Okay, so when you cross multiply here, that means our T1 plus T2, our T1, sorry for this, T1 plus T1 will be equal to class 2Tn. So, but there's something you should understand here in practical. Though this one is under assumption, it's practical. Everything here is just under assumption, you get. So there's something you have to know here from T1. Now there's an accuracy for T1. To get T1, this is what you have to do. To get T1 from here. Okay, there's an assumption from here. This TM here has a standard connection with TM. This T1 has a standard connection with TN. So the standard assumption of T1 with TM is this, that T1 is equal to TM minus 1. Please take note. Okay, now this minus 1 here is for accuracy. It's just a standard assumption, so they don't prove it. So T1 is Tm minus 1. So remember, we have Tm already, so to subtract that from 1 is very simple. Okay, but that means our Tm, there's a connection between Tm and the T1. That means our Tm here is already known. The only one that is unknown to us here is T2. So let's make T2 the subject. T2 is equal to T2Tm minus T1. Of course, class, this T2, this Tm is known, this T1 is known by subtracting Tm with 1, okay, or by 1, okay. When you subtract Tn by 1, you will get T1, okay. Now let's do that, please. Let's subtract Tn by 1. When you do that, Tn by 1 here will give us 21. That is 21. That is 22.10 minus 1 will give us 21.10, okay. Now the next one, 20.20 minus 1 will give us 19.20, okay. Now the next one, 18 minus 1 will give us 17.00. Please take note. 15.60 will give us 14.60. This will give us 11.80, okay. 11.80. 11.80, okay. So that means we have gotten our T1. Remember, this is the formula we use to get our T1 here. That is Tn minus 1 will give us that value, okay. So our focus now is on T2. So this is the formula relating with T2. Now it means multiply the Tn by 2, multiply the Tn by 2, subtract the value from multiply Tn by 2 minus it by T1. Multiply the Tn by 2 minus it by T1, okay. That means I will multiply this by 2. I multiply this one by 2, I will get 44.10. So sorry, 44.20 minus it from this, from 2 minus this one, 2110 from 2210, you get T2, okay. The same thing, multiply this by 2 minus this one from this, multiply this one by 2 minus this one from it, multiply this one by 2 minus this one from it, multiply this one by 2 minus this one from it. So that's how we that's how to get T2, okay. That's how to get T2. So let's solve this. Multiply this one by 2. Very simple. This is the formula. This is the formula in case you have forgotten. This is the formula here. Multiply Tn by 2 minus T1 from this. When you do that, we have something like this. Let's do it together, okay. So 2 times 22.10 is 44.2. So that means 44.2 minus 21.10. My T2 is 23.10. So the next one here, 2 times 20.20, 2 times 20.20, the answer is 40.4. Subtract that from 19.20. So 19.20 subtract from 40.4 will give us, that's 19.20. I will have 21.20, okay. Now the next one, times this one by 2. So 2 times 18 give us 36. 36, 17, subtract 17. 36, that is minus 17 is 19. We have this as 19.00. So the next one, this times 2, 2 times 15.60 is 31.2. 31.2 minus 14.60. 16.60. Okay, I will have to be 16.60. Now the next one is 12.80. 12.80 times 2, now minus 11.80. So I'll have this to be 13.80. Okay, so class, how do we calculate T3, T4 if there is T5? Also, depending on the practical manner you are using. Okay, so remember, T1 is for odd, T2 is for even. Please take note. So T3 is for odd, T4 is even. Please take note. So this T3 will take the time of T1. This T4 will take the time of T2. The T5 will take the time of T3 or T1. Okay. Now, very simple here. I will write down T3 as 21.10. This will be 19.20. This will be 17.00. This will be 14.060. 11.80. Now this will be 23.10. This will be 21.20. This will be 19.00. 16.60. This 13.80. Okay, now let's confirm if this answer is correct. If the answer is correct, if I plus this, this, and divide it by 4, I will get this guy here. Let's do it. 21.10 plus 23.10 plus 21.10 plus 23.10. Okay, divide by 4. So I will have the answer is, you can see the answer here, 22.10. Okay, so all you have to do to get the answers to this practical manual here, is to hit the subscribe button and you'll get all the answers. You can also WhatsApp us for some of the materials. Okay, okay, you get some of the materials on our website. Just get some of our materials from our website. Just WhatsApp the number that will be posted here to get some of our materials from the website. Okay, thank you.